Good morning, Stats fans. How we doing on this fine Thursday morning? Yes, it is Thursday morning. Weeks tend to be going pretty quick now, which is good. Weeks are going fast. It's going to be nice today for a while, so I suggest go out and enjoy it because it's supposed to turn a little yucky tomorrow and Saturday. They even said chance of snow. Today, it's a celebration day. It's a celebration day. This is the last of the new material that we'll be covering. I need to dab the tears from my eyes. It's the last of the material. Oh boy, last of the material. This is the last of the new material. Tomorrow, what we will do tomorrow, I will give you an in-class assignment tomorrow. I will give you an in-class assignment tomorrow for you to work on and get it back to me. Monday will be a review day, and Tuesday will be a chapter, a unit test over chapter 7 and chapter 8 put together. And that will be the last of our tests. From that point, we will start prepping for the final. We'll spend 3 days reviewing for the final, and then we'll do the final the following Monday and Tuesday. And we'll be done with the class. Woo! Yeah, we go. That's what I'm talking about, Jack. Today we're going to talk about testing two means again, but now we're going to look at the t-test. We did the z-test yesterday. We're going to look at the t-test today. Okay, once again, possibilities for the null-Alton hypothesis is not changing. Now, the one thing that we had to worry about in a t-test, though, is we had to worry about degree of freedom and looking at a t-table. What you do with the degree of freedom is you're going to have two groups. You're going to have two groups here, group 1 and group 2. You want to take the smaller sample size to determine the degree of freedom. So you look at what sample size is smaller, and you utilize that degree of freedom when you're finding your critical values. Okay, so when you look at your sample size, you look at the smaller sample size, and then we do a degree of freedom of that, and then we find our critical values from that. How we calculate our test value is the same way, and once again, as before, this is going to go to 0. We have to include it in there because when you get to upper level statistical analysis, these may not be equal. So if they're not equal, then we can sit there and we can calculate a value at that point. They may not be given as equal. Okay, we have x1 divided by, or xx1 minus x2. Okay, now we have two different values that we have to worry about. We have this, which looks like what we did yesterday with the t-test or with the z-test. And what I suggest you do is go ahead and have it on an index card or put this on your t-table. Okay, you could put these values on your t-table, and how you calculate this, once again, I've told all my classes leading up till now, always put these on your t-table so you can have a reference to them. Okay, I'm not expecting you to memorize them. I don't memorize them. I don't know them. If I need to look them up, I look them up then. If I need them for some reason, I look them up. We use this when we have two different scenarios. When the population variances are unequal, we utilize this right here, and it will be stated within the problem. When the population variances are unequal, we basically use the z-test idea that we did yesterday. Standard or variance divided by sample size, variance divided by sample size, and take the square root of that. That's what we did yesterday with the z-test. When the population variances are equal, this is where it gets a little bit muddy. Okay, this is where it gets a little bit muddy, when they're equal. And once again, I suggest you have this written down so you can refer to it. We have a sigma hat times the square root of 1 over n1 plus 1 over n2. Now, how we find sigma hat? This is how we find the sigma hat here. This is what is given to us, but what I'm going to tell you is when I take n minus 1, this is degree of freedom 1. So we have degree of freedom 1 times the variance of 1, plus a degree of freedom 2 times the variance of 2. Now this n1 plus n2 minus 2, this is n1 minus 1 plus n2 minus 1. That's both of their degree of freedom. So really this is degree of freedom 1 plus a degree of freedom 2. And what this does is sort of cleans this up a little bit. It more or less refers to the degree of freedom, which is a lot easier than dealing with all the quantities that are there. We use this when the population variances are equal for this sigma hat. Okay, so we had two different scenarios that we had to look for, and the problems will tell you what you have to deal with. If we go to the back side, ACT scores of 12 males and is 21.1, standard deviation of 5. Mean ACT score for 15 females, high school students is 20.9, standard deviation 4.7. Same problem we did yesterday, alpha value 0.01. What we've changed here is we've changed the sample size. Alpha value 0.01, can you reject a claim that the male and female students have equal ACT scores? Assume the population variances are equal, which is the uglier of the two. We have to do that sigma hat thing. So just like yesterday, and if I'm going too fast, slow me down by hitting pause. Group 1, we'll make the males because they come first. So we have N1 is 12, so degree of freedom 1 is 11. The X bar 1 is equal to 21.1, and the sigma 1 is a value of 5.0. Group 2, females, we have N2 is 15. Degree of freedom 2, that means that's 14. Their mean is 20.9, and their variance is 4.7. Let's see. Can you reject the claim man females have equal scores? So we have the null, mu1 equal, mu2, the alternate, mu1 not equal to mu2. So we have a two-tail test. We are two-tail. So we look at our bell-shaped curve. We have a two-tail test. Our critical values, once again, we want to use our t-table. Now, the degree of freedom that is smaller is the one we want to use. We have 11 and we have 14. So we're going to use a degree of freedom of 11. So we have a two-tail test. 0.01 is my alpha value. 0.01, two-tail. I'm going to go down to the degree of freedom of 11, 3.106. A negative 3.106. So there's my critical values. Our t-test. We have x bar 1 minus x bar 2. x1 minus x2. So we have x bar 1, which is 21.1 minus 20.9 minus mu1 minus mu2, which we said this goes to a value of 0. Now what we have to deal with on the bottom is that Sx1 minus x2. And that's where we start running into what we have to do. The variances are equal. So we have to look at sigma hat square root 1 plus and 1. So we have our sigma hat times the square root of 1 over n1, which is 1 over 12, plus 1 over n2, which is 15. The sigma hat, since they are equal, our sigma hat is equal to the degree of freedom 1, variance 1, plus degree of freedom 2, variance 2. So the sigma hat, let's see, degree of freedom 1 times variance 1 plus degree of freedom 2 times variance 2 over degree of freedom 1 plus degree of freedom 2. So we have the square roots. Degree of freedom 1, which is 11, times my variance, which is 5 squared, plus degree of freedom 2, which is 14, times 4.7 squared, don't forget to square it. And this is all over degree of freedom 1, which is 11, plus 14. So on top we have 11 times 25 plus 14 times 4.7 squared. And we're going to divide that by 25. So we get square root of 23.37. Second square root, second answer. We get 4.83 for this sigma hat. Now this value here we have to multiply. That is this value here. It's 4.83. So I'm going to keep the value in my calculator. I'm just going to hit times square root of 1/12 plus 1/15 plus 1 divided by 15. Get me out of there. And we come down to this value then is equal to 1.87. And once again, that is this value here. So to find my test, I take my two values here, 21.1, and I'm just going to hold my value in my calculator. I'm going to quantify 21.1 minus 20.9 n quantity divided by my answer, and I get a value of 0.1068, which throws in here, which once again we could agree that there should be no difference between males and females. So we fail to reject the null hypothesis. Looking at one last problem here with this. And once again, if I'm going too fast, just slow me down by hitting the pause button. Personnel Director, Florida claims that the mean household income is greater in Hillsborough than it is in Polk County. In Hillsborough County, sample of 17 residents has a mean household income of this, and standard deviation in Polk County, they have 18 residents with that mean income. Okay, we have group 1, which I'm going to say is Hillsborough, because it comes first. N1 is equal to 17, which means degree of freedom is 16. Their income is 49,800. Standard deviation 4,200. In group 2, we have Polk. We have, let's see here, N1 is 18, degree of freedom is, I'm sorry, that's 2. Degree of freedom 2 is 17. Their mean household is 44,400. So that's 2, and S2 is equal to 8,600. Okay, we have to do a null and alternate hypothesis. Let's see here. We have one's greater than the other. So, let's see. Hillsborough is greater in Hillsborough than in Polk. So I'm going to go mu1 is greater than mu2. That means here mu1 is less than, that's greater than or equal to, mu2. Let's change that around. Mu1 minus mu2. Yeah, let's change that around. Because what he wants to true is that alternate hypothesis. So if we take a look, we have one tail. It's right. Oopsie. There will be a right tail test. So we go to our t-table again for a critical value. We look at which one's smaller, which is this one here. So we have a degree of freedom of 16. Alpha value of 0.10, and we have a one-tail test. So we have a one-tail test, 0.10. We go down to 16, we get 1.337. Now, assume the population variances are not equal, which is the easier of the two. This just goes back to z-test. It reverts back to a z-test on the bottom. So we have our t-test value, x bar 1 minus x bar 2 minus mu 1 minus mu 2. Once again, that's going to go to 0. And then we have over the S1, x1 minus x2. Now how we calculate that, it's a lot easier. So if we take a look at our t-test, x1, which is 49,800 minus 44,400 minus 0 over this s x1 minus x2. Once again, this value here is easier when they are assumed to be not equal. Which is this right here, assumed to be unequal. So we have this value here is calculated by the square root of variance 1 over N1 plus variance 2 over N2. So this is just our standard deviation. We're going to have to square that. So we have, let's see, 4,200 squared divided by N1, which is 17, plus 8,600 squared divided by 17, or by 18, and we're going to take the square root of that. So I can clickety-clack, second square root, 4,200 squared divided by 17 plus 8,600 squared divided by 18. Pull myself out of that. We get 2,268.6. That's going to be my denominator, and once again, I'm just going to hold that value in, and I'm going to quantify the numerator. So if I quantify 49,800 minus 44,400 and divide it by my, answer, I get a test value of 2.38, which is out here in this range. This is critical, non-critical. So we can reject the null hypothesis. We can reject a null hypothesis and state that yes, it is. The people in Hillsborough do make more money than Polk. Once again, it is a lot easier when the population variances are not equal. And I'll give you a hint. When we take the test next week, I'll put the one where you're not equal to on there. It makes it a little bit easier. But we need to be able to go through both of these, unequal to and equal to. Once again, this is the last of the material that we will be covering. I'll post some more problems on Google Classroom tomorrow. The only thing I'll have for you, unless you have any other questions for me, I will just post an in-class assignment for you tomorrow for you to complete. You'll have the weekend to complete, but the quicker that you get it back to me, the quicker I can give you some feedback on it, but I'll give you the weekend to be able to get it done. Monday will be a review day. Tuesday will be the Chapter 7 and Chapter 8 unit tests that we have. So we are quickly coming to an end with the material that we are covering, which is a good thing. That's a good thing. I hope everything's going well for you and your family and your household. I hope everybody's staying illness free. Once again, go enjoy some of the warmer weather today, because tomorrow it ain't going to be like that. They're calling for snow. So hopefully you'll be able to enjoy some of the warm weather today. Other than that, I have nothing else for you. I miss you guys. I wish you were in classroom, but it's our reality. So we just go and live the next day, okay, which is fine, okay. Other than that, once again, I have nothing else for you. Adios, folks. Have a great day.